So hello everyone, let us solve another LeetCode problem, and the problem name is maximum matrix sum. So you are given an n cross n integer matrix. You can do the following operation any number of times. So choose any two adjacent elements of the matrix and multiply each of them by -1. Then they have given the definition of what is adjacent element. So two elements are considered adjacent if and only if they share a border. In the end, your goal is to maximize the summation of the matrix element, and in the end you need to return the maximum sum of the matrix elements using the operation that is mentioned above. So what the question is saying, that you are given a n cross n matrix. There might be some values positive, some values negative, and what you need to do, for in one operation you need to choose two elements, multiply each of them by -1, and by doing this operation you need to return the maximum sum that you can get. So how we can get the maximum sum by doing this operation? So if we need the maximum sum, that means we want negative values to be as minimum as possible, and whatever positive values that we have, we need to maximize its magnitude. Then only we'll be getting the maximum sum, right? So this is what we need to find out, how we can do this particular thing. So let us understand with the help of first example how we can solve this particular problem, or what all observations that we can derive from this particular examples. So this is the example 1. So first they are taking these two pairs and they are multiplying by -1. So this will become -1, this will become +1. Then they are choosing these two elements which are both of them -1. So if you multiply both of them by -1, both of them will become +1. So in the end your entire matrix is positive matrix only. So if you take the sum, so you will get your sum as 4. That will be the maximum sum possible, because if each and every element is positive, that could be the maximum that you can get. So that's why you can see the answer is 4. Now did you observe one thing? When you have the pairs of two negative numbers, you can always make them, both of them, to positive. So can't we say that if we have two negative numbers in the matrix, we can somehow try to club those together, or take those two pairs as the adjacent elements and multiply by -1, because in this case these negative numbers were apart from that. So we can try to get negative numbers to be adjacent. So that's why we first choose these pairs, so that we can get the two negative numbers as the adjacent values. And if we have the two values, both of them negative, so we can obviously, by applying the operation, convert both of them to positive. So can't we say that if we have two negative numbers, so we can always convert them to positive? Yes, this is one observation. Now is it only limited to two negative elements? No, we can indirectly say that if we have even number of negative elements, so if we have even number of negative elements, let's say negative, then we can always convert all of them to positive. Why? Because if we can convert two negative numbers to positive, so obviously if we have even numbers, we can try to group two numbers and we can convert all of those two numbers to positive. So let us see another example, another scenario, to understand in more better way. So this is the example that I have taken. I am not giving the values, I have just taken the signs by negative and positive. So in this case you can see that we have 4 negatives, 1, 2, 3 and 4. So in this case our final goal should be to make each and every element of this matrix to be positive, because here we have even number of negative elements, so we can convert every negative to positive. So first we will try to take these two elements and we'll multiply by -1. So this will become positive, this will become negative. Now we have negative numbers that are adjacent. Now if we have the negative numbers adjacent, we can always take these two numbers as pair and multiply by -1 to make both of these two positive. So now we have both of these elements as positive. So let me just rewrite this thing again. So this was positive. After applying on this, these both also became positive. Now what we can do, we can take these two pairs, which is one negative and positive. So now this will become positive and this will become negative. So let me just write this again. So now this is positive and this is negative. Now again we will choose these two pairs, because now we have the two negative elements as the adjacent pairs. So we choose these two numbers and multiply by -1. So in the end this will also become positive. So you see, our entire matrix is now became positive. So what we can say from this? So we can say that if we have even negative numbers, so if the total number of negatives is even, then in that case our maximum sum will be nothing but the total sum of matrix, because indirectly we will be taking the total sum of the matrix only, because we have converted each and every negative to positive. So just directly take the sum, or you can, if you are keeping track of negatives and total sum in the same loop, you can take the total sum by absolute value of matrix of I comma j, because in that case will not actually apply the -1 operation. So that's why just take the absolute value, because we know that in the end our answer is going to be the total sum. So just take the absolute values and add it to your total sum. Now this was the case of even number. What about odd negatives? Because that is the only case remaining. So let us observe one thing in the odd numbers, odd case. So if we have odd numbers, odd number of negative, let's say we have 1 2 3 4 5. So if we have 5 odd numbers, there will be only one negative number remaining, because we can always choose two pairs together. So if we have odd numbers, then only one negative number should be remaining that we cannot pair with anyone. So in that odd number case, we will be just having one negative number, otherwise our total sum would be same that we were doing in the even case, just we will having one negative number that we need to subtract it from our total sum. So let us see one example to understand in more better way. So this is the second example in which we have three negative numbers, 1 2 and 3. So what we did, we clubbed these -2 and -3 together, so we made them positive, and the only negative remaining number is -1. So you take the sum of all these elements and subtract -1 from it. But is it really the exact case that we need to do? Because if we have odd number of negatives, so we will try to convert as max negative magnitude numbers to positive, because that is when only we will be getting our maximum sum, right? Because if you have negative numbers as -2, -1 and -6, you won't convert these two negatives to positive. Instead you will convert -6 and -2 to positive, because these have the larger magnitude even though they are in negative. So after conversion this will become +2 and +6. So this higher magnitude can contribute more maximum to our total summation. So let us see what I am saying with the help of another example. So yes, this is the example that I am taking. So in this case you can see we have three negative numbers. So we will try to make maximum magnitude negative values to positive. So in this case we have -6 and -5. So we will be clubbing this together and we will be making them positive. So our matrix would look something like this: +5 and +6. Now we will have only one negative remaining element. So what you can do, you will take sum 1 2 3 5 6 2 3 and 1 and then subtract -4, right? No, you will not do that, because since we want to maximize our sum, so the negative value should be also as minimum as possible, right? In this case you can see -4, it is not the minimum negative value. You can pair these two numbers, you can make this -4 to +4 and you can make this +1 to -1. So our final matrix would look something like this: -1 +4 and rest all remaining elements. So you will take sum 2 3 6 5 4 1 2 3 and subtract -1 from it. So that is what we need to take care in the case of odd number of negative elements. So what you will be taking care, you will be taking care of minimum absolute value. Whatever minimum absolute value you will have, you will subtract it from our total sum. So total sum minus minimum absolute value. But this is also not the actual case. You will be subtracting minimum absolute value twice, because you will be keeping track of total sum and negatives in single iteration only. So what you will be doing, you will be taking your total sum as +1, +2, +3, +6, +5, +4, +1, +2 and +3. So your total sum has all the elements of the matrix. Now since you need to subtract -1 from that total sum, so you have already contributed the +1 into your total sum. So first you need to remove the contribution of +1 from your total sum, and then you need to contribute a -1 to your total sum. So that's why we will be doing two operations, or that's why we'll be subtracting twice the minimum absolute value from our total sum. So this is how we'll be solving this problem. So let us just summarize in short what we are doing. So if the total number of negative is even, so obviously we can pair each of the negative numbers and make it positive. So in case of even, your final answer would be nothing but the total sum of the matrix, because in this case each and every number in the matrix is a positive number. So in the case of even, just return the total sum of the matrix. In the case of negative numbers, you have seen that if you have negative number, if we have odd number of negative elements, we can pair 2, but in the end we will be remaining with one negative number. So you try to take the value, one negative value as minimum as possible. So in case of, if the total number of negative is odd, you keep track of total sum and you keep track of minimum absolute value, and that minimum absolute value you will try to negate it. So in case of total negative number is odd, then take total sum and minimum absolute from the matrix and return this as your final answer, total sum minus twice the minimum absolute value. Why twice the minimum absolute value? Because in total sum, let's say your minimum absolute value is 1, so in your total sum you have already contributed +1 to your total sum. So first you need to remove the contribution of this minimum absolute value from your total sum as a positive number, and since you try to negate this value, now you take its negative contribution. So that's why we are doing twice the minimum absolute value. So in case of even, just return the total sum. In case of odd, just return total sum minus twice the minimum absolute value. So this was it about this explanation part. So let us see the code now, how we are going to do this in terms of code. So first we are keeping track of negative numbers, and I have declared n as the size of the matrix. I am also keeping track of the total sum, which is initialized to 0, and minimum absolute value initialized to int max, because since we want this value to be as minimum as possible, so we are initializing it with as maximum as possible. So now we are just iterating on the matrix, and we are keeping track of minimum absolute value, which is nothing but compared with minimum absolute value and the current absolute value in the current element. Now if the current element is negative in the matrix, then we increment the negative count by 1, and side by side we are also keeping track of the total sum by taking the absolute value of the current element. In the end we will just check if the total number of negative is even, then simply return the total sum. Otherwise, if the total number of negative is odd, then return total sum minus twice the minimum absolute value. So this is what we need to do in this particular problem. So this was it about this particular solution. So I hope you learned from this solution. Thank you for watching.